Harris's Science Multimedia project, the topic being global positioning systems. Now you're probably curious to know what a global positioning system actually is. Well, a global positioning system is a space-based global navigation satellite system that is able to pinpoint the location of any signal receiver on the surface of this Earth. Now this means that anyone is able to determine any unique location on the face of this planet. Now for these reasons, a GPS system, which has revolutionized not only the scientific areas of surveying and navigation, has been able to enable us to do many things that we couldn't have beforehand. Now, you can actually buy a handheld receiver for less than $1,000 Australian, which can undergo the process I'll explain later in a matter of minutes, which can give you your location. Now, there are currently 30 satellites part of the GPS system, almost 20,200 kilometers above the surface of the Earth. In fact, GPSs are now being built into phones and cars, and especially when driving, they make people's lives a whole lot easier. Now in this project I'll be exploring how the GPS works and its impacts on society, but first allow me to guide you through the history. I hope you enjoy my multimedia presentation. Now the history of the GPS is actually quite a fascinating one, and like most of the inventions of the time, the concept of the GPS derived from solely military technologies. Now the GPS system was created and realized by the US Department of Defense, and in 1973 they made the decision to make a satellite navigation system that was based on military technologies that were existing in the US Army and Navy. Now, although the GPS system was created in 1978 with 11 satellites, it only ceased being a solely military system in about 1983. But first, let's have a look at a system that helped to influence the global positioning system that we are familiar with today. In 1979 there was a decision to expand the system. For now though, they only decided to increase it to 18 satellites. In 1983, when a civilian airplane of the Korean airline was shot down by Soviet fighters, the GPS system was moved from being solely military to a public project. Civilian use would now be allowed. In 1988, they decided that the functionality was not good enough with 18 satellites, so 6 more were launched to make 24. In 1993, it was definitely decided to authorize the worldwide civilian use free of charge. And in 1995, a full constellation of 24 GPS satellites is in orbit. Full operational capability is also announced. Now let's get down to the real deal. How exactly does the global positioning system work? However, before we continue, it's important to know that on any given point on the Earth's surface, there will always be at least 4 satellites hovering above the Earth's surface. So even as I stand here, hovering above this surface on the horizon will be at least 4 satellites. So if I had a signal receiver, they would have been able to track my location. Now you'll understand the significance of this once I undergo the explanation of how a GPS system works. There are 3 factors which are used to determine the location of a signal receiver using the GPS system. The first one is latitude, how north or south something is from the equator. The second one, longitude, used in global navigation for east-west measurement. And last of all, altitude, which is height above sea level. Now using these 3 factors, latitude, longitude and altitude, any one point on this Earth can be given a set of coordinates for its absolute location. The GPS satellite transmits signals, radio waves, to a GPS receiver. The receiver is able to interpret this signal or code as information about the satellite at any given time. The receiver is then able to determine how far away that satellite is. See, radio waves travel at the speed of light, almost 300,000 kilometers per second. Although this is extremely fast, it is not instant.
The signal from the satellite will lag behind the matching code in the receiver by just a little bit. The receiver automatically measures this lag and uses it to calculate the distance from the satellite. Using the formula distance equals speed times time, we can simply find how far the distance between the satellite and the sphere on which the receiver is. The speed, being the speed of light, and the time, which the GPS receiver can measure. Now what you can see is the formula to find that distance.
However, remember, we do not measure the distance using only one satellite, but 4, which comes back to the reason why there are always 4 satellites above any given surface of the Earth. Now let's see how any 4 satellites are able to pinpoint the exact location of a signal receiver.
The first satellite tells you that you're somewhere on the edge of this sphere. The sphere intersects the Earth at this circle, so if you are on the ground, you know that you are located somewhere within the boundary of that circle. The second satellite narrows down your location to 2 points on the ground, where the circles intersect with each other. The third satellite pinpoints one location on the ground, and the fourth satellite corrects for differences that are present in the clocks on board the satellite and in your receiver, and nails down your position to an exact location.
So basically, your location is where these spheres intersect. Your receiver will then combine this information with inbuilt maps in the receiver to help them figure out where exactly you are in the world. Now, it is also interesting to know that most handled GPS units have an accuracy of about 10 to 20 meters.
You can't touch this. You can't touch this.
Now, let's take a look at how the global positioning system has positively impacted on our society in various different aspects.
Not only does the GPS system provide latitude, longitude and altitude, but time as well. Each GPS satellite has various atomic clocks that can send very precise time data to signals. Now this enables users who have a GPS receiver to determine the time to 1/billionth of a second. Communication systems, electrical power grids and financial networks all rely on precision timing. Of course, the reason most people would think of is for drivers when on the road. The GPS system can give sophisticated maps of the roads and highways which many find useful as a substitute to road maps, which rely on navigation skills. Now this really extends to all civilian use where location is needed to get from one location to the next. Aviators around the world use the global positioning system to improve the safety and efficiency of flight. This is because the system is very accurate and there are continuous providing services that give further precise measurements for pilots. New and more efficient air routes have also been made. One of the most important components of making a rescue mission successful is knowing the precise location of the disaster and the location of streets, landmarks and hospitals to therefore reduce time and save more lives. The GPS industry is a $10 billion one and has provided jobs to hundreds of thousands of people around the globe. As you can see, it has benefited our society as a whole economically as well. So these are just some of the very few examples of where the GPS system is able to achieve a superior outcome.
So there you have it, the uses and the applications of the GPS system. Pretty useful tool, isn't it? So now for a commonly asked question. Why don't satellites such as those in the global positioning system fall to Earth or float further out into space? And how does it keep its position and circle the globe without floating away or allowing the Earth to pull it in?
As you are probably aware, the satellites belonging to the GPS system orbit the Earth and have a gravitational pull to the Earth, just as the Moon does. Satellites have to go at a speed such that the centrifugal force, or the force that pulls away, in this case away from the Earth, exactly counterbalances the pull of gravity. Since GPS satellites are low Earth orbit satellites, the satellite must go relatively faster to maintain this equilibrium.
Another question that's commonly asked, how is a satellite such as the one in the global positioning system launched into orbit? Now for a quick and easy answer.
All satellites get into orbit riding on the back of a shuttle and sometimes a rocket. A satellite is launched at least 27,000 km per hour to obtain orbit. Any less and it will fall straight back to Earth.
We forgot to do the acknowledgements, bro!